Hello and welcome to Mr. Jackson's class again, chemistry, and we're going to continue on where I talk about heat and energy. And today we're going to talk about energy but in the terms of heat. We did temperature the other day, okay? And so let's talk about what is heat. Heat, and we're also going to bring up the idea of calorimetry, as you can see on our slides on the right, and here I have our notes on the left. Remember, you can stop the video anytime and do a screenshot and take the notes that you need, okay? So heat is defined as the amount of energy that moves between two objects. Okay, and so we know the sun. The sun is an object that puts off energy, heat, and it flows into the earth. So heat would become what comes from the sun. Okay, so it's the energy being transferred. Okay, are heat and temperature the same thing? And the answer is no. We see them, they're related, but they are not the same thing, okay? Heat is energy that's moving between two systems. Temperature is the motion created by that heat, and it doesn't always create the same temperature. So let me give an example between sand and water, okay? Here we have the sun, and the sun is giving off heat waves, okay? So this is the heat. And we know it's present because you've felt it before. But let's just say here I have this beach here, and over here is the water. Okay? So heat is what's being transferred both to the water and to the sand. Okay? And if you've ever been to a beach, you know that about 1 or so in the afternoon, the sand is extremely hot. That means its temperature is extremely high. Okay, so it's way up here, and it actually hurts your feet to walk across it. Okay, but if we put a thermometer in the water, and we've ever been to a big body of water like a lake or even a Great Lake or an ocean, we know that the water is extremely cold, even though they've been exposed, the sand and the water, for the same amount of time. They've both been exposed, they both have absorbed heat, but their temperature responses are different, okay? And so heat is the energy that goes into something. Temperature is the response of that material to change its vibration. So the sand will actually vibrate much more quickly. Okay, so heat flows in, but temperature rises, and then when heat flows out, temperature cools. So at night, the sand will cool down quite quickly, but the water will not cool down as quickly. Okay, so remember our hand idea. When we have energy going into something, we can feel it in our hands. If it feels warm, energy is going into our hands. And if energy is going out, then the heat is dropping. So at night, the energy in the sand would end up going back into the air. And so then what would happen is the thermometer would begin to drop again. Okay? And so we know that as heat moves between systems, temperatures do change, but heat and temperature are not the same thing. Okay? Heat is the energy that goes in, temperature is the response from that heat. Okay? Let's move on. What is calorimetry? Calorimetry is the study of how heat affects the temperature of different materials. Okay, and we use it to help study the law of conservation of energy. Okay, and that's very important. So calorimetry is when we study how much heat goes in and how the temperature responds. It's looking at these two together and see how they work. And why does the sand get hotter? And so we can actually study this effect, and we call that effect of heat and temperature changes calorimetry. So it's a study of the calories. Same thing when people do nutritionists. They study the calories, how much heat will come off a certain amount of food that you digest that runs your body. Okay, and if of course you eat too many calories, then your body doesn't have a chance to use it up. It'll store it as fat. Okay, but this law is following the law of conservation of energy. Okay, it's not very difficult, but it is a mathematical thing. So we're going to do some math today. Okay, so calorimetry. What is the calorimetry formula? Okay, here's the calorimetry formula. It is Q equals m times delta, which is a triangle, T, which just means change, times Cp. So these three things are being multiplied by each other. Q is heat, which is most time in joules, okay, which is J. Sometimes they will do it, they'll give it to you in calories once in a while, but we'll also do it. We're going to do it in J. Change in temperature is going to be degrees Celsius. It can be in degree Kelvins, okay, but that means you have two temperatures, so be careful. It's change in temperature. So if I go from 10 to 25, the change I would use in the math is 15. If I change from 50 to 90, then the change I would use in the formula is 40. So that's just the change in the temperature. Okay, M is the mass of how much you're heating up, and you know that when you're heating more material or less material, it doesn't change as quickly. So if you put a big pan of water on to boil noodles versus just a cup of water for some coffee, it takes longer to heat up that big pan of water. So how much we're heating up, the mass, is very important, and that is grams we use for that one. Specific heat is what I just talked about when it comes to this idea, okay? Specific heat is the way a material changes to its heat that it's exposed to. Let me explain that a little bit better. So here's my equation to the right, calorimetry. Here are the units, okay? Here is the equation, and then here are the units for each one. And specific heat actually has 3 units. It's joules divided by grams and degrees Celsius. So there's 2 units on the bottom, okay? And it has 2 sets of units. And we're going to show you some more of those ideas. And there are some ideas you can look in your book. And I believe I just changed books, so you can look on page 80 in this new book, and you'll see some specific heat values for different materials. Okay? So let's go on and talk about that. Specific heat, let's talk about that. The definition is it's the amount of energy or heat that it takes to change 1 gram of material to change it 1 degree Celsius. Okay? What does that mean? Here's what it is. It says like this. If I take and put a certain amount of heat in water, how much energy does it take to go up 1 degree? And how much energy does it take to go up 1 degree for the sand? Well, the sand has a lower specific heat. So it can jump very quickly. I think, just for an example, water has a specific heat of 4.18 joules per gram degree Celsius. Okay? So that's the specific heat value. It's got a number rating. Okay? Sand is 0.978 joules per gram degree Celsius. And so what happens is this can hold more energy per gram than this can. So the moment heat hits it, it can't take the heat, so it quickly rises up, but then it quickly cools off at night. This one takes a long time to rise up in temperature, but then it takes a long time to cool off, okay? It doesn't change as fast. So specific heat is how well a material can absorb energy. And different materials absorb energy a bit differently. So is the specific heat for every material the same? No. And so in your book on page 80, we have a list of specific heats. Lead can take very little heat. It quickly changes temperature. Iron can take it a little bit better. Aluminum, even a little bit better. Water is the best. Water has a very high number, 4.184, and so it goes up very slowly. That's why a lake or an ocean, even though it's out in the sun all summer, it barely gets warm. But then it stays warm late into the winter because it holds that heat for a long time. So a specific heat is a number rating that tells you how well something holds the energy. A low number means it heats up quickly and cools down quickly. A large number means it warms up slowly and cools down slowly. So in your notes here to the right, I've got some other ones. Here's an iron rod, which has a CP of 0.38. And iron quickly heats up. That's why you can't hold a metal stick and poke in a fire, because that metal will quickly get hot. Okay, but you can take a piece of plastic and poke it in the fire, and it will take a long time to get hot up this thing because it has a higher value. Okay, so here are some examples of some specific heats. Well, how do I use these ideas to do some math? Well, it's really quick and really easy. Let's do some problems with this idea, and let's figure out how something will change temperature or respond to heat. So we're going to do some practice problems with calorimetry. Okay, so here we go. We're going to go into chapter 3 into our new book, and we're going to do some problems today. And what we want to do problems on calorimetry and figure out what they do. So with that in mind, let me pull up a problem here. Here we have temperature and heat capacity right here. Okay, and let's do a problem on page 83. Here we go. We have our sample problems written out here, and let's do this. First thing you want to do is you want to find all of your energy and all of your given information. So we know that we want these simple ideas. We want to find the information provided in this question. So let's quickly look through. Here we have a temperature, 29.9 degrees Celsius. So we have a temperature, 29.9 degrees Celsius. I keep looking through my numbers before I read it and try to figure out. Then it says 2.5 grams G of gallium. I remember that's a mass. Okay, 2.5 grams. And then I go on down, and then I find from 25 to 29 degrees Celsius. Oh, so it's going up in temperature. It's going from 25 to 29. And that's good because remember, we're going to need the change in temperature in our problem. Okay? And so then it says the specific heat, which is the capacity, and that has a symbol of either C or CP in most chemistry books. Okay? So I'm going to be using CP in my notes. It says this value, and I know it's a CP number because it has 3 units after it. Okay? So is 0.372 joules per gram degrees Celsius. Okay? So here's the 3 things I've got now. I wrote down just my given information. I wrote down my temperatures, my mass, and my CP number, and it told me it was a CP number. Now let's go back and read. It says if you hold this in your hand and it melts with your body heat, how much heat? Well, heat is the symbol Q. Okay? So write down the numbers you're given according to their symbol. Masses get an M, temperatures get a T, specific heat numbers get a C or CP, and then any number that has a joule you would put by the Q. Okay? And then we're going to use our equation, which we wrote down as right here. Okay? So I'm going to write this equation down, and then I'm going to plug my numbers in where they belong, and then the missing part I'm going to put in X. So here we go. Q equals M times delta T times CP. So I'm going to put my numbers in. X goes here, which is perfect. So this is what I want to find. Okay? And I just got to put these numbers in. M is 2.5. Change in temperature is, remember, it's a change between these two. So I would just take 29.9 minus 25, and I would put in 4.9 degrees, because that's how much the temperature is changing. Okay? And then I would put in my specific heat of the chemical we're using, and it happened to be that we were dealing with this material, gallium. Okay? And so we plug our number in, and its value of absorbing heat is 3.72 joules per gram degrees Celsius. And we see the Celsius cancel out, the grams cancel out, and I'm going to have a joule left over on top. So that's perfect. So now all I got to do is multiply my 3 numbers. 2.5 times 4.9 equals times 0.372 equals, and I get 4.557 joules. So 4.557, and joules would be the leftover unit because I know that all Q numbers or answers have to have a J after it. So let's see if we're correct. Here they did the same thing. They wrote down their given information. They found the equation right there, and I use a capital Q. They use a little q, and then there's their C, and they've got an answer of, final answer for them is down here 4.6 joules. I wrote 4.557. If we cut off at the 4 point, that would be also 4.6 joules, which is perfect. Okay, so that's how you do these problems. Let's just do one more to make sure you understand. Okay, here we have a problem, and we'll write our equation out here. So remember, our calorimetry equation is as follows. Q equals M times delta T times CP, and we are looking for these ones based on their units. Remember, these have joules, these have grams, these have Celsius, and these have 3 units. So let's look at our problem. This is number 311 example problem on page 84 in your book. A student finds a shiny rock and thinks it's gold. So she weighs the rock in a balance and determines that its mass is 14.3 grams. So that's an M, that's a mass number. So let's write that down. M is 14.3 grams. Okay. Then let's just go through the numbers. It says, let's just scan through really quick. Here we have 2 temperature numbers. So we know we're going to have that for our change in temperature. So our delta T is going to be, it goes from, she heats it up from 25 to 52. So 52 minus 25, and that'll be my delta T right there. And then it goes on and it says after it absorbed 174 joules. That has to go by the Q number. 174 joules. Joules go by the Q. Okay? So then it says, it goes on and it says, now find the heat capacity. Now another name for specific heat, I noted in your notes, is heat capacity. Specific heat, another name for specific heat is heat. It's the capacity to hold heat. So I remember we told you a larger number means it's better at holding heat. It has a higher heat capacity. So sometimes that's the terminology they use. So we want to find CP. So I'm going to put an X here and then plug all my numbers in. So here we go. Q, 174 joules equals 14.3 times the change, 52 minus 25, is 27. And then my specific heat is what I want to find. So that's the number I want to find. So X is all by itself. Okay? So if X is by itself and I'm timesing by everything, then I'm going to divide by these two on both sides so I can move them over 14.3 and 27 degrees Celsius, and then 27. So then these cancel out and X is by itself. So I'm going to take this and divide it by these two numbers to get the X. So 174 divided by 14.3. Whoop. Okay. Divided by 14.3 equals, divided by, again, 27 equals, and I got 0.4506, so I'm going to call it 0.451. So 0.451, and it's going to have all these units, joules on top, and then grams and degrees Celsius on the bottom, because it's a CP number. So I want all 3 units. And let's see if we got it right. And we go on down, and we see that they do the given list. They put the numbers in. They subtracted the temperatures, plugged everything in. They divided the things over they didn't want. We did divided 2, and they got an answer of 0.45 joules over gram degree Celsius. So that's how you do those problems. You find the given numbers, read the question for what they want, put an X in that spot, wherever it goes, and then rearrange if necessary, and then solve. And that's how you solve those problems. Thank you very much for joining me today, and have a great day.